is an example of a bus timetable. On the left hand side you've got all the different places where the bus on this particular route stops, and then in each column, each of those columns is a different journey that the bus makes during the day between Monday and Friday. You'll notice that there are some places which don't have a time against them. If they don't have a time against them, that means they don't stop at that place. So we're going to look at some very simple questions that you might be asked involving a timetable. So the first one says, what time does the 14:10 from Chippenham arrive at Rowdy Crosskeys, and how long is the journey? So let's find that 14:10. So that's the 14:10. So we go down until we find the Rowdy stop, which is here. So we can see that it gets there at 14:47. And if we left at 14:10, that means it's taken 37 minutes to get there. Second question. Sarah wants to get to Devizes by 11 AM at the latest. What bus should she catch from Chippenham bus station? So we need to work backwards here. So we're going to look at Devizes times, and we need to find the one that will get her to Devizes before 11 o'clock. So the one that's closest to 11 o'clock but not after 11 o'clock is here. And now we need to work backwards and find out what time that bus leaves the bus station in Chippenham. So if we work backwards, we can find that it's 10:20 that leaves. Sorry, it's important that it's 2 dots there, because otherwise we might be tempted to think that that's a decimal and it's a time, not a decimal number. So our third question says, which bus journeys from Bromham to Rowdy are the shortest? So here's Bromham, there's Rowdy, so they're right next to each other, so that's going to make life easy for us. So we just need to go along and calculate how long it takes to get from Bromham to Rowdy, and then we'll be able to work out which ones are the shortest. So the first one is 7:32 to 7:38, so that's 6 minutes. The next one is 9:15 to 9:22, so that's 7 minutes. Then 10:04 to 10:11, that's 7 minutes. 10:40 to 10:47 is also 7 minutes. 11:40 to 11:47, 7 minutes. 12:40 to 12:47, that's 7. And another one that is 7, and another one that is 7. 17:19 to 17:26, that's also 7 minutes. And then 18:03 to 18:09 is 6 minutes. So now it's fairly obvious that the two journeys which are the shortest are the ones that leave Bromham at 07:32 or 18:03. Now here what we have is a train timetable. So it works very much in the same way as the bus timetable. We've got the destinations, the stops on the left hand side, and if there isn't a time, it means it doesn't stop there. Now the numbers along the top indicate that you will actually have to change trains to get to the final destination. So Ross lives in Chippenham and is planning to visit his gran in London for the day. His gran is going to meet him at Paddington at 9:30 AM. So which train will get Ross there in time? So we're looking for trains at Paddington, looking for the ones that are going to get us there before 9:30. So the one that's right before would be this one. It gets us in at 9:24, and that train leaves Chippenham at 8 o'clock. So I'm going to pose a second question to you. Why might he actually choose to get the train that leaves at 7:55? One possible reason why he might get the 07:55 train is because he won't have to change. He's only going for the day, but if he was going with luggage, that might be a bit of a bother. So notice that over the 0800 we can see the little one there. That means that at some stage he would actually have to change trains. The other reason you might give for why he would pick that train over the other train is the fact that it actually will work out faster. Let me prove that. So we've got the 0800 that gets in at 09:24. That's a fairly easy time calculation. So that's 1 hour and 24 minutes. Now let's work out the 0755. So that's 0755. Now it gets in at 0912. So that's not quite so straightforward. So we're going to bridge. So we'll go to 8 first of all. That's 5 minutes. Then we'll go to 9. That's 1 hour. And then 9:12 is another 12 minutes. So altogether that one takes 1 hour and 17 minutes. So technically that one is a faster train. Going to use the same train timetable again, but this time Debbie lives in Swindon and is planning to visit her friend Rachel in Reading. It takes Debbie 20 minutes on the bus to get to the train station. Rachel lives a 15-minute walk away from Reading station. Debbie needs to arrive at Rachel's by 10 a.m. What is the latest time Debbie can leave home? So 10 o'clock she's got to get to Rachel's. So let's set this up. So we're going to work backwards. So we're going to have Rachel is the end destination. Before Rachel she arrives at Reading station. Before that she leaves Swindon station. Before that she leaves home. Needs to get to Rachel's for 10 a.m. She needs 15 minutes to walk to Rachel, so we need to take 15 minutes off that. That will take us back to 9:45. So we need a train that goes into Reading by 9:45. So let's have a look along the Reading values, and we can actually see there are two that both turn up at 09:44. So there are two that arrive at the same time. So let's see what the difference is when she leaves at Swindon. So she can either get on a train at 9:04 or 9:10. So let's assume that she gets on the later one. So it tells us that she needs 20 minutes to get to the station on the bus. So we need to take 20 minutes off there. We do that in stages. So to 9 o'clock that would be 10 minutes. And then 10 minutes before that would be 8:50. So the latest she could leave home would be 8:50. if she wanted to catch the 9:04, she'd have to leave even earlier. So in terms of what they asked, which was the latest possible time, 8:50 is the latest she can leave home and catch a train and meet up with her friend on time.